Here's an example of how you could complete the previous exit ticket. What you should do is pick some x values and put them in and figure out what it's going to be for y. So I'm going to start with 0. 0 is always a good thing to start with. So I'm going to put that into here. And for 0, that would give me 3 times 2 0 power. Now, the mistake I saw a lot of you guys made is you multiplied first. You did 3 times 2 and then raised that to the 0 power. What you need to do is do 2 to the 0 power, and anything to the 0 power is just 1. So that's going to be 3 times 1. So when x is 0, y is 3 times 1, or 3. So let's take a look at a couple more examples. Let's say I have the first power. That would be 3 times 2. Put in 1 for x, 3 times 2 to the 1. Now that's 3. It's going to be times 2. 2 to the 1 is 2. So that's going to be, when x is 1, it's going to be 3 times 2, or 6. And if I keep going with this a little bit, and let me do another one here. 3 2 times 2 squared. 2 squared is equal to 4. So that's going to be 3 times 4, or 12. So when I have 2 here, that's going to give me 12. By this point, I should have a pretty good idea of the pattern. I can see here that each time I go down, I am multiplying by 2. That's to be expected because if you look at my original equation here, this 2 to the x means each time x increases, you go up by an additional 2. So I can use this pattern now to fill out the rest of the table as much as I want. Going down, I get 3, and 12 times 2 is 24. And then if I were to go again, I would get 4, and 24 times 2 is 48. I can also go back in the other direction. Of course, in the other direction, I don't multiply by 2, but I would effectively divide by 2. So going up this way, I would get -1 would give me 3 divided by 2, which is 3 halves, or 1.5. Then it would be 3/4, 3/8, etc. It's going to get awfully close to 0 as to where it's really going to be indistinguishable from 0 on my graph. So I'm just going to do my best to draw a line that's close to 0. So now I'm going to go ahead and try to put this on the graph. This is going to be a little rough, and I didn't have the expectations were that you capture the basic idea, not that you have every point perfect. Okay, so at 0, I'm going to be right around 3. At 1, I'm going to be around 6. At 2, I'm going to be around 12. At 3, I'm jumping up to 24. I didn't specifically mark 4 on here, but that would be 48. So at that point, I'm already kind of like getting off the grid, like up here kind of a thing. So that gives us an idea of how that would look. At -1, I'm like at 1.5, then 3/4. You can see it's really hard to distinguish it when you get to these tiny values. But that's a general idea of what it's going to look like. So now I can kind of connect these guys together and see what my graph looks like and see how it takes off. And if you have the table here and you convey the basic idea, that's good enough. It's hard to make it perfect, especially doing it freehand like this. But I wanted to make sure you guys got the idea. And particularly, I wanted to emphasize the first thing, that you need to first raise to the power. You do the raising to the power before you multiply by 3. That's because in your order of operations, PEMDAS, exponents always come before multiplication. Okay, thank you.